can you please share it in your team? If you guys have matching answers, you're great. If you don't have matching answer, please figure it out. Billy, final answer, bud. What did you get?
5x minus 1 over x squared plus x minus 12.
Okay. Devin, do you agree? Yes, you're in the same team. Kristen, do you agree?
Yeah.
Yeah, all right, guys. So, let's figure it out. What do you guys do first? Yeah, what's the common denominator? X. What? X plus 4 times? Great. So this gets the same. Whatever you guys multiply to the denominator, we multiply to the? Yep. So this gets this. Over here, this 2 gets x plus 4. The denominators are the same, so we can put them together, right, guys? Then we distribute and then combine. Yes or no? Okay, so that's how Billy's team gets that. Now, that's back in the day. Now, I'm going to give you this, and you're going to give me the original, the fractions, okay? So let's, all right. Definitions. The reverse procedure, starting with the rational expression, 5x minus 1, y'all, divided by x squared plus x minus 12, and writing it as the sum or difference of two simpler fractions. In our case, it was 3 divided by x plus 4 and 2 over x minus 3. It's referred to as a fraction or partial fraction. Partial fraction decomposition. The two simpler fractions are called partial fractions. All right, number 2 says rational expression. So what is what's a rational number?
It's either a terminating decimal or decimal or
Yeah, right. So rational number is any number that you can write it in terms of a fraction, because rational, would you guys agree, is like a ratio, and a ratio is a fraction. So same thing with the rational number, except it now has algebra in it. That's it, okay? So rational expression is in the form of P over Q, where P and Q are polynomials, and since Q is in the denominator, it may never ever be 0. Definition number 3 says proper rational expression. So what's a proper fraction? It's less than 1. Would you guys do like 3 over 4? Is that a proper fraction? Is 4 over 3 a proper fraction? No. Okay. So proper rational expression, same thing with proper fraction. The numerator is less than the denominator. So same thing here. So is when the degree of P is less than degree of Q. Okay, let's talk about the word degree. What is the degree for a linear equation? 1. The degree is the highest power. What's the degree for a quadratic equation? Square, 2. What's the degree for a cubic? 3. So a degree of a polynomial, student, is one number. It's the highest exponent of the whole thing. Okay. Improper fraction, again, just like improper rational expression, is the same as improper fractions. When the numerator, it's higher. But in this definition, we're going to use degree. So it's when the degree of P in our definition equal to as well. So bigger or equal to degree of Q. All right, guys, there are 4 cases to decompose. So case number 1 says, to decompose P over Q, where Q, which is the denominator, has only non-repeated linear factors, okay? Under the assumption that Q has only non-repeated linear factors, the polynomial Q has the form. So here is the form for Q. So Q of X is linear, means the factor can only have a degree of 1, okay? So remember, these are factors, so technically I can have as many factors as I want. So dot, 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 all the way to x minus a sub n. Where no two numbers, a1, a2, dot, 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 an, are equal, because it says non-repeating. In this case, the partial fraction decomposition of P over Q is in the form of P of X over Q of X is A over X minus the first factor. In our case, it was like X minus a subscript 1 plus B over the second factor. However many factors that we have, students, that's how many partial fractions that we're going to get. So the last one is whatever the last factor is. Okay? Where the numbers A, B, dot, 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 N are to be determined by us. Okay, we're going to go to example 1, example 2b, and then we'll come back and fill in the cases 2, 3, and 4, okay? So go ahead and find example 1. Okay, example 1. Miss Lou, can you help us read the instruction for example 1, please? Good. So we have to say it's proper, improper. If improper, then we have to rewrite it as a sum of a polynomial and a proper rational. So example 1a, we need to find the degree. So Nathan, what is the degree on the numerator? On the numerator? 1, because this exponent, right, Nathan, has a degree 1. Nathan, what's the degree on the denominator? 3. So based on this, Nathan, based on your definition, would this qualify to be proper or improper? Did you say proper? Do you guys agree? Okay, let's move on. Easy peasy. If it's proper, we don't have to do very much. Annika, B, degree of the numerator is? 6. The highest one, not the combination. 4, And Annika, degree of the bottom is? 3. So based on this definition, proper or improper? Yeah, improper, because the degree on the top is more. Well, If it's improper, we can't quit. We have to go further. It said if it's improper, rewrite it as a sum of a polynomial and a proper rational expression. All right, I'm going to review some basic math with you. You don't have to write this, okay? What if I said proper, improper? 9, 8, 7, 4, 3 divided by 2. Proper fraction or improper fraction? Definitely improper. What grade do you guys do long division? Third grade. Sounds great. Teach me. I just came up from second grade. Don't know anything about long division. You guys are my teachers. A house. There's a house. Woo! All right, a house. 2 outside. And then what? The big number. Okay. Now what, cheats? Do what? So take 9 and then do what? Okay. And then now what? Okay. So what do you write on the top? Okay. Box it up? No. Now what? Multiply. Okay. And then what do we get? 8. And then we do what? Okay. Now what? 1. Okay. Now what? What do we get? Oh, I wrote something on the top. Okay. Multiply again? Now what? 18. Now what? Subtract again? Okay. Bring down 7. Don't you want to go back to third grade? This is so much fun. Okay. 7 divided by 2? 3. Now what? Okay, which is?
6.
Why would we keep subtracting? All right. Okay. Okay. Multiply again. All right. Subtract again. Okay. So much fun, guys. Let's keep doing this. Forget pre-calc stuff. Now what? Now what? Times. Subtract. Okay. Now what? Let's do remainder of 1. How do I write it as a fraction? 1 divided by 2? Like that? Is that the same thing as if we're going to go in and do that? Yeah, technically it's an addition of the fraction, right? The remainder. But because these are all, would you guys agree, number that we can be combined? So normally back in the day, we say just stick it at the end, right? Your remainder. We use the same thing in dividing your algebra stuff. Let's go. Okay, as you can see, we have an improper. We're going to make a house because that's what you guys told me. Okay, here's our house. Inside will be the numerator. But can you guys see in the numerator we have a degree of 4. But we're missing a few terms. So in the algebraic expression, if we are missing a few terms, guys, we will fill it in with zeros. Can you guys agree that we're missing a cubic term? Yes. So we're going to add 0, x to the third. Then we have an x squared, but we are missing a linear term. So we add 0x, and then we minus a 2. On the denominator, it goes outside your house, because that's what you guys said. We are missing 2 terms. What terms are we missing? A square and a linear. And then drop down. Okay. Just like what you said, okay? We're going to try to see how many times x to the third go into 3x to the 4. So how many times? 3x to the 4 divided by x to the third is 3x. Yes or no? I'm sorry, just like that. You wrote something on the top. You kept telling me to do what? Multiply. But we had to multiply to the entire thing. Okay? So 3x times x to the third is 3x to the 4th. 3x times 0x squared is 0x to the third. 3x times 0x is 0x squared. 3x times negative 8 is?
Negative 25.
Right. And then after you multiply, you kept telling me to do what? Subtract. Okay, so technically, students, we would subtract the entire thing. Yes or no? Subtracting the entire thing is the same as if we were to go in and change the sign to each and every term. Would you agree with that statement? Yep. So you can go in. So we're gonna now do what you told me to do. Combine. If we combine, the first two terms will be gone. What do we have here? X squared, plus 24x. And then, yep, drop down the 2. Even with dropping down the 2, technically we can go in and write a 0 because there's not. But would you agree that I can't really divide because it's not big enough? Would you guys agree that this would be the remainder? Now we added 1/2, so we're going to go in and add this over what? X to the third minus 8. And that's what they mean. X to the third minus 8. And that is your final answer. If it's improper, rewrite it as a polynomial. In this case, this polynomial only has one term, which is a monomial. And then a proper. Is this now a proper fraction? Yeah. Did you? I know you guys did long division in algebra 2.
Yeah.
Okay. The question is, it was distance learning. Not sure. Okay. We are now going to do example 2, and then we'll go back to do case 2 to 4. Katie, help us read the instruction for example 2, please.
Write the partial fraction
Decomposition?
decomposition of each rational expression.
Perfect. So guys, before you go in and give me the fractions that add up to equals to this, start with factoring everything out. Can we factor out the denominator? Is it factorable? Yes. Michael, what are the factors?
-2 and -3.
So you have to write it as a quantity, bud.
X minus 3 times x minus 2.
You guys agree? Okay. Check out, how many factors do we have for the denominator? 2. Each factor, first factor, is that a linear or is that a quadratic? Linear. Second factor? Linear. Are they the same or are they repeating? I'm sorry, that's the same. Are they different or are they the same? Different. So this is non-repeating linear. So we're going to go back to that and say, okay, what was the formula for non-repeating linear? It was what over what? A over the first factor, in our case, x minus 3. True or false? Plus b over the second factor. However many factors that you have, then that equates to how many partial fractions. Now our job is to solve for a and b. All right, let's test out your basic skill. Let's go. Here's what we're using. This is what we're using to solve a and b. All right, step number 1. What should we do? Combine? What do you mean?
Combine the both terms of x together with the other x.
Do you guys remember when you have fractions? You're right, in that same concept. When you have fractions, how do we clear out fractions so it's easier for us to solve? Multiply each and every term by, Sean? The LCD, right guys? So what is the LCD for those? X minus 3 times the quantity of L? That's right. Each and every term. Okay? All right, so multiply this by x minus 3 times x minus 2. This by the same. X minus 3 times x minus 2. X minus 3 times x minus 2. As you can see, stuff are going to cancel. First fraction, what's canceling? The entire denominator. That's why we love multiplying by LCD. The second, x minus 3 is canceled, so you have a times x minus 2. Third, x minus 2 is canceled, so now we have this. And from here, we will distribute, okay? So x equals a x minus 2a plus b x minus 3b. Next, we would try to group like terms together by putting all square terms together, all the x's together, and the non-x's together. So, ax plus bx, and then we're going to group negative 2a and 3b together. So far, so good? All right. As you can see, how many x terms do we have? 2. We would try to factor it out. A common factor, which is what? X. Okay, so now we have a plus b. Over here, we don't factor anything. We're just going to group them together like this. Okay, so this is where math comes in. Would you guys agree on this is an equation? That means on the left side must be identical to the right side, which our job is to find a and b, so that is true. If we go in, so let me ask you this. If we go in and I add a 0, does that change anything? No. If I go in and I decide to move a plus b in the front, does that change anything? No. But the reason I'm doing this so you can see where this manipulation of mathematics come from. All right. What number is in front of the x on the left side? What number? 1. Okay, now look at it. We have something x over here. We have something x over here. They both have an x. We have something of a constant, and this is a constant because there's no x. Would you agree? Because this is an x, this is an x. This has to equal to that. And this then has to equal to that. And that's how manipulation of mathematics is. Okay, so 1 equals to what then? That's right. Then that means 0 equals to what? Negative 2a minus 3b. Perfect. All right, now you solve for a and b. How would you like to solve a and b? System equation, yep. Substitution, elimination, graphing. Substitution. Man, I don't know why you guys love substitution so much. Okay, what would you do? B equals what? 1 minus a. Now what? Plug that into there. Okay, you plug it in there. What do you get? So we plug it in. So we get negative 2a minus 3 times the quantity 1 minus a. 0 goes negative 2a minus 3 plus 3a. And that means what? 0 equals a minus 3. So I mean a is 3. All right, how do we get b? Plug it in. You plug it in. You get an answer. Compare it with your team first, guys, before you box it up, okay? Okay, Matt, whenever you're ready. What's b?
-2.
You guys all agree? Okay. Now that we have those, we're going to write our partial fractions. We have a, we have b. We put it together. Okay, a is what? 3 over what? B is what? Negative 2 over? Right. Now, students, would it be the same? I'm going to write this. Would it be the same if I write it like this? Are these two the same? Yes, those are the same. Now, just to kind of jog your memory, guys, because a lot of you guys like substitution, but sometimes elimination is easier. So I'm going to write the same equation, okay? 1 equals a plus b. And then 0 equals negative 2a minus 3b. All right, students, if I would like to eliminate a, what should I do? Multiply the top equation by 2. If we multiply by 2, we will end up with 2 equals 2a plus 2b, a is reduced. Can you guys see this? And b come out to be? Yep. Okay, and then plug it in. So sometimes eliminations is easier and quicker. All right, let's go back to define cases 2 to 4, and then we'll come back and finish up as much as we can. Okay, cases 2 to 4. Okay. Case number 2 says, decompose P over Q, where now Q, which is your denominator, y'all, is repeated linear factors, okay? So what that means is if the polynomial Q has a repeated linear factor, say x minus a to the nth power, where n is 2 or higher, and n has to be an integer, then in the partial fraction decomposition, we allow for the terms a over x minus a, which is the first factor, plus b over x minus a to the second power. If n is 3, then you would have three partial fractions. If n is 10, then you would have 10, and then you would end at the very last power of x minus a to the 10th. In this case, it's an n. Okay. For the numbers a, b, ... n, again, will have to be found by us. Case number 3. Okay. Case number 3 is when we decompose P over Q, where Q, which is your denominator, is non-repeated, irreducible quadratic factor. Irreducible means we can't factor any further, okay? So if Q, which is your denominator, contain a non-repeated, irreducible, again, irreducible means it can't be factored further, quadratic factor in the form of a x squared plus bx plus c, then the partial fraction decomposition of P over Q allows for the term, since we only have one quadratic here, one factor, then we have one term here. Now, because the denominator, students, has a degree of 2, then on the numerator, we would have one less degree, which is ax plus b, where our variables a and b will have to be determined by us. Last case is when we have repeated, oh, too fast, sorry. Last case when we have repeated, okay, irreducible quadratic factor. So that means it's raised to a power of some sort, and that power obviously to be repeating, it has to be 2 or more. I'm sorry, so I'm going to use n. Okay, so 2 or higher. And again, n has to be an integer. Then the partial fraction decomposition allows for the term. If we have power of 3, then you would have 3 fractions. Okay. If you have power n, then there would be n. So here we go. The first one, just kind of like repeating linear, except that now we have quadratic. We will have ax plus b. Then the second, if it's 2 power, then this is where you would stop. Second of 2. Guess what next variable we're going to use? I will use a and b, so next will be cx, yep, plus d. And keep on going. If we have an nth number, then we will stop at an nth number. Ax squared plus bx plus c to the nth. And I'm going to use nx plus m. And the variables that we have to find are a, b, c, d, n, and m. Okay, let's go do example 2b and 2c. I don't think we have time for 2d. I'll leave it up for you guys to copy. right, let's go to 2b. All right, Matt, help us read 2b.
X plus 2 over x to the third minus 2x squared plus x.
Good. So guys, before we decompose, we have to factor out your denominator. So Matt, what can we take out? X, so we are going to have x squared minus 2x plus 1. Okay. Is that the end of our factoring? No? Can we factor some more? Yeah? What is it? X minus 1 squared. All right. Perfect. Okay, how many factors do we have total? 3. One of this is not repeating, right? Linear or quadratic? Linear, not repeating. This is also linear, but it is repeating. So we're going to have 3, a mixture of repeat and non-repeat. If it's 3 factors, we have 3 partial fractions. Okay. Each factor goes under each fraction. What do you think the middle denominator is? What do you think the third denominator is? Square. Yep. The numerator, this is a degree of 1 linear, so the numerator is 1 less, so we don't have anything but a constant. So we use A, B, and C. 3 fractions, meaning that you're going to come up with 3 equations. All right, let's clear out the fractions, guys. Multiply each and every term by x times the quantity of x minus 1 squared. Okay, are you okay with me saying, okay, this is cancel? So the first fraction on the left-hand side, what's cancel? Everything except the numerator. Would you guys agree? Yep. A over x, if we multiply it by the LCD, by the way, the LCD is always this. Okay, what's left? How about that? We'll use what's left. X minus 1 squared. The third fraction, what's left? X, and then there's another x minus 1. Would you guys agree? C over x, quantity x minus 1 squared, what's left? Yep, C and then x. Perfect. Then here we are going to FOIL, distribute, whatever we want to use, and then regroup. All right, let's FOIL x minus 1 quantity square. Hey, Carter, can you FOIL that one out for me? It should already be in, like, above. Yeah, there you go. All right, and then we're going to FOIL Cami. Is Cami here? I thought I marked her absent. Yeah, I thought so. Okay. All right, Bella, can you distribute that for me? What would we get? X squared minus x. Good. And then this is just cx. And then distribute some more. All right, here we go. Ax squared minus 2ax, or 2xa, that doesn't matter, plus a over here, plus bx squared minus bx plus cx. Guess what we do next? Yeah, group them. Okay, all. How many x squared terms do we have? 2. Yep. Okay, so would you guys be okay if we go ahead and add a 0x squared term? Yep, it doesn't change anything. We have 2x squared, so we are going to put those in the front. All right. Now, Cece, how many x terms do we have? 3, good. Let's put them together. So minus 2ax minus bx plus cx. We only have one constant, right, guys? Oh, that's nice. Okay, so this allows us to say, can I take out an x squared? Yeah. What's left? A plus b. Over here, what are we going to take out? Yeah, this whole thing, I'm going to take an x, plus x. What's left? Negative 2a minus b plus c, and then drop down an a. All right. Is it enough for us to write our 3 equations? Perfect. Equation number 1. Sean, give it to me. What's our equation number 1?
Squared, no. 0 is equal to 8.
Yes, only the constant is now used. Do you guys agree? All right. Equation number 2. Allie. So what number, Allie? Look on the left side, Allie. What is the leading coefficient of x on this side? Not x squared, but x. So which one is it? 1. You're right. Now look on the right side. What are all of the things that represent the coefficient of x? Right, and we take that, Allie, and set it equal to? Yes, perfect. Good job. All right, Jordy, third equation. Oh, nice. Guys, you have A. Yay. Woo-hoo. We got lucked out. Hey, what's next? What's smart to find next? B. All right, Brooke, go find B. Oh, nice. See? Plug it in. Brooke said B is -2. Someone confirm? What's next? All right, you guys find C. Confirm with each other before you guys circle it or box it. Once you have your answer, please talk to each other before we box it up. I know, try to squeeze. All right, Brayden, what's your final?
The letters or the final?
No, I'm sorry, what C is, my bad.
3.
3. Confirm, D9? Okay, let's box it up then. What do we have all together? Final answer. What do you guys write? 2 over x, yep. Plus -2 over x minus 1 plus 3 over. See, not too bad, right? All right. C, and then we'll go over your homework. My cell phone said we have 11 minutes for C. You think we can handle it? Yeah, let's do it. All right. And then we'll save D for Friday. All right, Eve, help us read C, please. Great. Before we decompose, we have to factor. Is it factorable?
Yeah, it's just x minus 1 over 3.
Yeah.
No, because then that'd be -3x in the middle.
Is it factorable? The denominator? Guys, there's no case for a cubic. We don't have a cubic case. Right? Have linear case, quadratic case, no cubic case. So guess what? It is factorable. Who remembers SOAP? SOAP is just for COVID?
I know I did it. I don't know it.
All right, y'all. Then let's write this somewhere. SOAP, okay? If you are given a cube minus b cube, okay? SOAP. SOAP, anybody remember what that stands for? Same, opposite, always positive. You're right. So the sum and diff of cubes are always factorable. Okay? So a cubed minus b cubed, based on the SOAP. What's your first factor? A minus b. Well, not the our thing yet. We're just gonna write the formula first. Yeah, a minus b. What do you guys remember about the second factor? A squared. All right. A squared. All right. SOAP stands for same sign. So if this is a minus, this will be a minus. And Sophia said earlier, next O stands for opposite. So the next sign is plus. Plus what? A times B. Oh man, you guys. Plus B squared. Whew. All right. Let's write the sum formula as well. All right. The sum of cubes. Formula says SOAP. So what do we start with? A plus B. And then A squared minus AB plus B squared. All right. Okay, y'all. Your denominator is something cubed minus something, right? So what will give me? So when we take it to the third, it goes x to the third. X. Okay, so that means your A is x. What's to the third? So that when we take it to the third, it goes 1. Yeah, exactly. So your equation is 5x plus 2 all over. Factor that for me. A is what? X minus 1. A squared is x squared. Plus or minus? Plus. Plus what? A times B. X, because 1 times x is x. Plus b squared. Plus 1. Look at that. Okay, how many factors do we have? 2. So you know there has to be 2 partials. The first factor, linear or quadratic? Linear. So for linear, what's on the numerator? A. Second factor, quadratic or linear? What's on the numerator? AX plus B, but I already used A, so the next would be BX plus C. How many variables? 3. So guess how many equations you're going to end up? 3. All right. Let's rock and roll. Step number 1. Clear out your fractions by multiplying each and every term by the denominator. So would you agree the whole denominator here is gone? So now I just have the numerator left. When we multiply the middle, what is left? X squared plus X plus? Yep, because the other terms cancel. When we multiply the third, what is left? X. Yep. All right. Let's distribute. Okay, so this is ax squared plus ax plus a. Distribute this dude out correctly. That's going to be bx squared minus bx plus cx minus c. Someone confirm that really quickly? Yeah. Next, what do you do? Yeah, group them. I'm going to add a 0 x squared over here. Is that cool? All right. How many x squares do we have? 2. Okay, yep. So ax squared plus bx squared. Okay. Eve, how many x terms do we have? 3, 1. Yep, 2 and 3. So plus ax minus bx plus cx. Dana, how many constants do we have? 3 or 2? 2. You guys agree, Dana? All right. From here, can I straight up write the equations? Yeah. If you're comfortable, do that. If you're not, then factor. Okay? If you're comfortable, straight up, write your 3 equations. If you're not comfortable yet, then factor. Okay. All right. Equation number 1. Josh, give us our first equation, please. I know. Look how pretty that is. All right. Sophia, give us the second equation, please.
A minus b plus c equals 5.
Okay. And last, Emily? Yes. Okay. Pre-calc skills over. Now let's resort back to Algebra 1. Huh? Elimination with 2 equations, Sean. Well, we can only do 2 at a time. First 2, okay. If we do the first 2, what are we eliminating? Okay, so what do we have left? What do we have? Let's do the constant. 5 equals 2a plus c, right? Because the b's gone. Perfect. Now what? Last 2? Okay. Like that? Oh, okay. The one we just made, oh, I just erased a number. Remember, you can eliminate 2 at a time. What was the number 2? Okay. We're going to go over and write that over. 2 equals a minus c. And we are going to eliminate, what are we eliminating, Sean? C, so what do we have? Okay. Are we good to solve A? Perfect. A is what? Yes, we got an A. Out of the 3 equations, students, where do we plug it back to get your next variable? What do you want to solve for next? A, B, or C? Well, we got A. So B or C? B, which equation? First, all right, you guys plug it back, you solve for it. Before you box it up, make sure you have a matching answer before you box it up, okay? And once you have that, go straight and solve for C as well. And once you have all 3, write your partial fraction in the bottom. But remember, confirm your B and C first before you write your final answer. Hey, Devin, what did you get for B? Confirm? All right, perfect. And then Katie, what do you get for C if you're there? 1/3. Is that confirmed? Yeah? Okay, so let's plug it in. We have final answers. Okay, something over x minus 1, and A is what? 7 over 3. Plus B is negative 7 over 3x, plus C is 1/3 all over x squared plus x plus 1. That's it. Do not try to find a common denominator and put them back together, because if you do, then you're going to get the original question. So yes, it looks ugly because that's the point. All right, guys, homework. Let's rock and roll. Who is brave enough to start? Yes, Michael.
Can you do 23, please?
Yes, 23. Give me the background.
So
So x equals secant t and y equals
Secant
tangent t.
Y equals one more time?
Tangent t.
Okay.
And we're limited to negative pi and 0
To 0 like this? Inclusive or non-inclusive?
inclusive.
What do you want me to do?
I just didn't know how to graph it right.
Graph? Does it just want us to graph?
Yeah.
Okay. Is it just graph Y? No rectangular? Because I want to make sure. Huh? That's the wrong restriction. Okay. 0 to pi over 4. Maybe that's why, Michael. Okay. So t, x, and y. Is it just graph? No rectangular as well? Okay, so t, without a calculator, I don't have a lot of choices, right guys? Only have 3 values that I can do without a calculator. True or false? All right. Secant is the reciprocal of which? Cosine. Let's find cosine, just flip it, okay? All right, here we go. Cosine of 0 is 1. Flip 1 is still 1. Well, tangent is what over what? Sine over cosine. Okay, so at 0, sine is 0. Cosine is 1. 0 divided by 1 is always? Yep. All right, cosine of pi over 6. Rad 3, I'm going to flip it. Is that okay? So 2 over rad 3, which is really 2 rad 3 over? Yep. Tangent of pi over 6. What? Rad 3 over? Final answer. Is that all right? Yes, no, maybe? Okay. Cosine of pi over 4. Rad 2 over 2, but let's flip it. So what's the final answer? 2 rad 2 over 2 is just rad 2. Okay. Tangent of pi over 4. I like that. It's 1. Looks like it's all positive, right, guys? So I don't need negative. So let's see. 1 is 0. This is my starting point. Does it ask for orientation? Yeah. Okay. 2 rad 3 over 3 is about what? Because I just need to plot. 1 point something. So it's a bit. And then rad 3 over 3, that's going to be 0.9. Okay. A little bit over 1, a little bit less than 1. Someone confirm that dot for me. Looks about right. Yeah. Rad 2, it's over 1. Is that okay? And then go up 1. So, someone like that? Yes, no, maybe so? Ends right there. It shows orientation. Someone confirm that for me? Something like that. Rectangular. Anytime, students, that we have trig, then we have to use Pythagorean theorem of trig. We don't have sine and cosine. We have secant and tangent. What is the Pythagorean theorem that involves secant and tangent, Billy?
Tangent squared plus 1 is secant squared.
Is that true? Yes. Every time we see, remember, tangent square, student, is like this. Because I think this is where some of you guys struggle. Tangent square of t is the same thing as write tangent of t and then square outside. Same thing with all of the trig. Right? So every time we see a tangent, we plug in what? Y. So y squared plus 1 equals. Every time we see a secant, we plug in x, and that's x squared. You can leave it. You can move and solve for y. That's really your personal choice. So if you move, this is another way to write your answer. If you want to do plus or minus, would you guys agree? All of the variations. Okay. Now restriction. I can't have it go on forever. So what is the domain restriction? It can only be from where to where. So my smallest x is, let's see, my smallest y is 0. Right, guys? So to get y equals to 0, x will have to start where? X will have to start where? 1. All right. The largest y is 1. Would you guys agree? So the biggest x has to be rad 2. True or false? Yes, no, maybe? Because rad 2, quantity square, will give me 2. 2 minus 1 is 1. Yes or no? Okay. Why did I find the 1? What do you mean? For the x restriction?
Yeah.
Oh, because I figure I need to make this equal to 0. So to make it equal to 0, only 1 minus 1. And the only thing that was squared would be 1 is 1. Yeah? Michael, is that okay? Where do you think you went wrong on your homework?
I just don't even know where I could have gotten that other domain restriction.
Oh, sometimes like below.
That just set me up for failure.
Sometimes like your eyes kind of like go to the right or left or below or top, you know? All right, others. Yes, Katie.
53.
Yes. Give me the fact.
So it says the girl throws a baseball with an initial speed of 145
Wait. 145. Okay.
per second at an angle of 20 degrees to the
Wait, slow down. Angle is 20 degrees.
the horizontal.
Okay.
The ball leaves his hand at a height of 5 feet.
Okay, 5 feet.
And so the first question is find the parametric equations that model the position of the ball as a function of time.
Perfect. So would you agree that we gave you the projectile motion?
Yeah.
Okay. So there's an x and there's a y. He's throwing the ball straight up, Katie. If it's thrown straight up, do we have any horizontal displacement of the ball?
No.
So you can give x anything you want to give it. What do you guys want to give it? 0, 1, 2, 3, 4. It doesn't matter. But even if you don't and you use your equation, guys, your equation is velocity cosine, right, of an angle times t, right, students? What is this angle? It never gave it to you. But it's going straight up, so it has to be 90, right? So what's cosine of 90?
Yeah, it doesn't throw it straight up.
Huh?
It doesn't throw it straight up.
Oh, never mind. It's 20 degrees. Woo, I lied. Never mind. We have an extra degree. Okay. Let's try that again. Yeah. Cosine of theta. Sorry. Somehow. I heard straight up, but. Yeah, I lied. It's not straight up. All right. So we actually have an angle. So of t, and this is 1/2, -1/2 times gravity times t squared plus velocity times cosine of an angle times t plus, sine, thank you. All right, and then plus h. All right, Katie, are these okay?
Yeah.
All right. Katie, what is your v sub 0?
It would be 145 degrees.
Perfect. What is your theta?
20 degrees.
Perfect. Make sure your calculator is in degrees. And then this is just going to be times t. Is that okay? Over here, Katie, what is the g value we need to use for this question?
Is it 9.8 or 10?
Good. Is it 9.8? It's feet, Katie, so we can't use 9.8. Find 9 points per meter per second square. 32 because it is in feet. Yep. And then your t squared stays. And then this one is sine. So 145 sine of 20 bubbles times t. And the h value, Katie, for this question is?
5 feet.
5. Perfect. Now, students, without a calculator, you can leave the 20 degrees as is, okay? So if you don't have a calculator, you can leave it in that form. The y is now -16t squared plus 145 sine of 20 degrees times t plus 5. All right, part 1. Where did you get stuck at, Katie?
So graphing it.
Okay.
Finding the maximum height.
All right, so that's part A. What did you do? What's part B?
how long is the ball in the air?
Okay. How long is the ball in the air, students? It's asking for what? Time or height? Time. For us to decide how long it's in the air, we need to know when it lands on the ground. So which equation will allow us to do that? Y. So it lands on the ground, Katie. Y will be substituted with what value? 0 equals. Okay. As you can see, it's definitely not factorable. So now what? How do we solve? Huh? You solve for t. How do we solve for t? Quadratic what? Formula, right? Okay. X equals negative b. B is this whole term in the middle. Would you guys agree? So negative 145. Sine of 20 degrees. Is your calculator in degrees, Katie? Make sure that's in degrees. Plus or minus square root b squared 145 sine of 20 degrees square minus 4 times a. A is negative 16. C is 5. All over 2 times negative 16. All right, Katie, step by step. Take your calculator. Again, make sure it's in degrees. Punch all of that in and then give me a number. And you guys too. If you guys missed this, practice your calculator skill. Mode has to be in what? Degrees. It's 20 bubble. 15 sine 20 bubble minus 4 times 16 times 5. Right. Under the radical. Whenever, Katie, you're ready, give me the number.
Negative 0.097.
Can't be negative if we're under the radical. So did you do 14 sine, open parentheses, 20, close it, and then it has to be square, right, Katie? You guys have positive or negative? Positive. What number do you guys have? Huh?
3.2.
Did you get a positive? $145. How about this? Katie, do this. Do 145 sine of 20 degrees. Do one step at a time, okay? Hit enter. And then where? Oh no, I'm just asking you to do the under the radical. Yeah, no, I just want you to do under the radical to make sure we're correct.
145 sine of 20 degrees.
Yeah, and then hit enter.
45.5.
And then square it. Okay, now, and then minus 4, open parentheses, negative 16, close it, and then open another parentheses times 5. We're going to do one step at a time, you see.
2,700.
Yeah, we got a big number. Okay, so now do square root of that number. So square root, Katie, and then hit second answer. Beautiful. 52.72. Is that cool? All right. So over negative. Okay, so now because of the plus or minus, we are going to separate these. 145 sine of 20 degrees, Katie, add 52.72 divided by negative 32. That's one answer that you need to give me. And then the second is the minus part of it. So do the addition first. So just do the numerator, hit enter, and then divide by negative 32.
For the additional, I got the same answer, the negative 0.9.
Negative 0 point what?
Yeah, for the addition one, so when you're, it's negative 145 sine 10 plus 52.
Uh-huh.
Divided, I got negative 0.0797.
0697, like this.
0.0977.
Okay, like that?
Yeah.
Okay, go ahead and do the minus. Maybe I misunderstood you earlier, because I think I... Oh, earlier you did the whole thing, right, Katie?
Yeah,
Oh, got it. Then my bad.
and then 3.197.
Okay, so would you agree that t is seconds?
Yeah, and 2 seconds after the
So we can't use that. So that would be, so it's in the air for about 3.2 seconds. So what? So that one, what happened on your homework?
I think, I'm not sure, I don't think I understood how we talked about it like that, I needed to do that.
Yeah, that's okay. And then what's part C?
Determine the horizontal distance that the ball travels.
Okay, so now horizontal distance, Katie, which equation are we going to use?
X.
Yeah, so now we're gonna take x and we plug what time frame in for x?
The 135 feet per second. The velocity initially.
Well, we have x equals, right? 145 cosine of 20 degrees, right? Katie, times t?
Yeah, so then you would just input the time.
Input the time that we found, yep, because that's when it lands on the ground. So when it lands on the ground, that will give us a horizontal distance. Go and punch it in, let me know what you get.
$435.
435.6, and this is feet, right? All right, next part, Katie.
When the ball is at the maximum, or when is the ball at its maximum height? Determine the maximum height.
So when means time, right, guys? So we're looking for the vertex. So could I graph all of this out and solve? Which equation should we graph out to solve for the vertex? Which equation? X or Y? It's you. The Y. So Katie, you can graph it out and find the vertex, Katie. Go to the Y equals, Katie, and plug in what, Katie? Negative 16, yep, negative 16 t squared, perfect. Which you're going to have x equals, okay? Are you back into the non-parametric? I want to make sure. Yeah, make sure it's back to function. Negative 16 x squared, and then it's going to say, next is going to be plus 145, and we have sine of 20, and then plus 5, 20x. So we're going to do 20x, and then plus 5. Okay. Now in the window, Katie, hit window. What does x represent in this context?
The horizontal distance.
No, in this equation, x does not represent the horizontal distance.
The time.
The time, right? The time, so can time be negative? No, so our x min would be what? 0. What is the max time of this person fell involved? Yeah, so I'm gonna write 4. X max is 4. Are you cool with that? Hit zoom and zoom fit. Do you see a parabola? Yes. And then you trace for it. Again, x represents what, Katie? Time, right? And then in this particular case, when you trace for the maximum or the vertex, Katie, y represents what?
the height.
Yeah, and then that should be the answer. Is that the last part for this?
Shady says use a graph and it's
Oh, perfect. Oh,
Or when it tells you to graph a simulation, you don't have to.
yeah, no, I don't need you guys to do simulation, okay? All right, next part. Yes, Allie.
On number 51, it says Bill's train leaves at 8:06 a.m.
Wait, hold on. Leaves at 8:06, okay?
It leaves at 8:06 a.m. and it accelerates at the rate of 2 meters per second.
So does that mean second square? Uh-huh.
Bill, who can run 5 meters per second,
Wait, runs 5 meters per second, uh-huh.
arrives at the train station 5 seconds after the train has left,
Ooh, sucks to be Bill, man.
and runs for the train. And then part A says, find the parametric equations that model the motion of the train.
All right.
And Bill as a function.
All right, so x equals y equals x equals y equals. All right, Allie, would you agree that there will not be any vertical displacement? Right, so what would you like to give each y? Personal choice, really. So there's no vertical displacement, so that means y equation can be anything you want it to be because it's not important. Okay, 1 and 2, 0 and 1, right? It doesn't matter. Okay. For the train, Allie, in the question, because this is your first time using acceleration, what did it give you?
It gave us s equals 1/2 at squared.
A t squared. Do you guys agree? It gave you this hint because you've never seen it. Now, Allie, what does s in the equation tells you in the problem?
Accelerates at the rate of 2 meters per second.
No, s. Let it s.
The position is s.
Yeah, the position of the train or whomever, right? So the position, Allie, would you agree that also means the horizontal place? So we, up to this point, we have been using x, but students, s and x, they mean exactly the same. So Allie, they give you s is half times acceleration. What's the acceleration that they gave you?
2 meters.
Yep, so 2 and then times t squared. So your x equals just straight up t squared. Bill has a speed of 5 meters per, but he arrived, what? 5 seconds after the train has already departed. All right, part B, Allie, what does it say?
Determine algebraically whether Bill will catch the train. If so, what?
Yeah, to determine algebraically, we will set the two locations to be identical. Then we are going to distribute. After we distribute, we are going to see if we can move it over and set it equal to 0 because it says use algebra. All right, Allie, we can't factor. So if we can't factor, what would you like to do? How do we solve if we can't factor? Quadratic? Yeah, you guys have to get this under your belt, okay? So the quadratic formula said b squared, right, guys? I'm sorry, negative b. b is negative 5. So 5 plus or minus square root b squared minus 4 times a times c all over 2 times a. So Allie, what is negative 5 squared under the radical?
25.
Great, good job. What is negative 4 times 1 times 5, Allie?
500.
Beautiful, all over 2. Allie, under the radical, do we have a problem?
It's negative.
Yeah, so is it possible to do a square root of a negative? No. So guys, It's not possible. We cannot come up with the time, so therefore, Bill missed his train. All right, next question. Uh-huh.
Can we do 57?
Okay, what is it, hon?
A Toyota Camry traveling east at 40 miles per hour and a Chevy traveling north at 30 miles per hour.
Whoa. Impala, travel what?
Traveling
North.
at 30 miles per hour.
30 miles, okay.
Are heading towards the same intersection.
Intersection, okay.
The Camry is 5 miles from the intersection and the Impala is 4 miles from the intersection.
All right, so this is 5 miles. Impala is down here. This is 4 miles, okay? All right, y'all, here's the intersection. North, south, east, and west. The Camry is going this way. The Impala is going that way. True or false? All right. Part A. Any?
Find parametric equations that model the motion of the Chevy.
All right, Cam, Impala. All right, y'all. The Camry is going east. So would you agree, based on that model, horizontal distance, it's okay, but vertical is not, right? So I'm gonna pick 0. Horizontal distance, it's 40 miles per hour, and it is how far away? How far away from the 5? So can I minus 5? Yes, no, maybe? Impala, can you guys see that's going up? So based on that, the y value will count, but x does not. True or false? And it is speed is 30 miles per hour, t is hour, and it's 4 miles down of the intersection. Yes, no, maybe? Okay, part B. Annika.
Find a formula for the distance between the cars as a function of time.
Ooh, yeah, okay. Distance, it's x1 minus x2 square plus y1 minus y2 square. Can I switch to the y2, y1? Yeah, it doesn't matter because it's square. All right, y'all. X1 is 40t minus 5. X2 is 0, right, students? When I minus 0, does it change anything? Nope. And over here, if we minus 0 again, it doesn't change anything. So can you see that's my final equation? Annika, you okay with that? You don't have to distribute. Leave it. Don't waste your time. What's your next part?
Graph the function.
Oh, yeah, let's graph. Okay, let's enter that in. When we enter this in, Annika, your t is the x variable. Make sure you're no longer in the parametric. Is that cool? You are now graphing normally, like unit 1. All right, so enter in square root 40x minus 5 close the quantity square, and then plus 30x minus 4 close the quantity square. Now guys, if these cars are 4 and 5 miles from the intersection, would you agree, and their speed is 30 and 40 miles per hour, would you agree it's going to take them less than an hour to meet up? So your x max should only be what? Window, x max should be what? 1 hour is the most it's going to take. A lot less than that, really. So, so time is non-negative. So x min will be 0, x max will be at most an hour. Hit zoom and zoom fit. What should we have? You mean like a V. Remember, your x min is 0, the x max is 1, because it's not going to take that long to meet up. So hit zoom and zoom fit after you enter in 0 and 1. There you go. All right, so it looks like a V. X is going to be time, and Y is distance, right, Annika? and you have this. Would you agree? Okay, part D, what does it want?
What is the minimum distance between the cars? When are the cars close?
Yeah, so would you agree the minimum is that? You trace for that, you answer the distance, so the y will be the distance, and the x will represent the time in hours. Does that make sense? Okay, try that on your own, and I'll take one more question. Next question. Hey guys, if you are tracing this, it's going to be a small decimal, but that's going to represent the hours, a fraction of an hour. Okay, so if you check the back of the book and it converts to minutes, then it might have a different number. Does that make sense? All right, y'all. Other questions? I'm waiting for one particular question because that's so difficult. Oh yeah, thank you so much, Bella. All right, give me the one with the log and the e. What? Give me that one.
The log is C3.
Okay, yeah.
X equals e to the t power, and then y equals e to the t power,
Mm-hmm.
and then the restriction of 0 is the natural log.
Of 4? Okay. All right, guys, let's, I know we're going to run out of time, so I need you guys to really, okay, let's review some log stuff. Let's do exponential first. Some number, let's call it 5 to the x plus, when you guys multiply number with the same basis, what do we do with the exponent? We add them, right? So would you get that this is 5 to the x plus y? 5 to the x divided by 5 to the y. What do we do? 5 to the x minus y. 5 to the y raised to the, or 5 to the x raised to the y? 5 to the x times y. Okay. So far you guys are doing great. Log base 5 of x equals y. Can you please write it in exponential for me? 5y equals x. Beautiful. These are equivalent. They are just, okay. Then, guys, if we have log of any base of x plus log of the same base of y, when the logs are adding, we can rewrite it as a multiplication of log. And so guys, write this down because I'm not going to go do this again. Log base b of x minus log base b of y is the same as log base b of x divided by y. Okay. Then in log, we also have powers. Okay, here we go. Log base b of x, y'all, to the y is the same as multiplying the y to log base b of x. Students, natural log of x is the same as log, but what base? E. You're right. Okay, so we need all of that to kind of do this. Here we go. To graph this out, we make a chart. So that's not a big deal. My time is 0, natural log of 1, natural log of 2, natural log of 3, and natural log of 4. They already gave you, oh, why am I making a line for it? They already gave you the x equals and the y equals. All right. You can go if you want, but you can say if you want. Okay, so e to any 0 is what? 1. 2 times 0 is 0. E to the 0 again is 1. If you guys use your calculator and enter in natural log of 1, what do you get? 0. Guys, so that means these two values are exactly the same. This is the part where it's difficult here. Now we enter in e. E to the, again, if you go, just go quietly. E to the natural log of 2. If you guys don't remember, students, this right here means it's 1. So 1 times 2 is 2. Yes, that's exactly the way that is. And we will prove that for you if you want to. Then over here, we got 2 times t. But again, t is natural log of 2. So this is the same thing as e to the natural log of 2 to the second power. Well, what's 2 to the second? 4. So that's why this is e to the element of 4. And again, this is 1. 1 times 4 is 4. So if you get the logistic, this is just going to come out to be what? 3. This is e to the second times natural log of 3, which is e to the natural log of 2 to the 3 to the second, which is what? 3 squared is 9. And e to the natural log of 4, that's going to be 4. Then e to the 2 times natural log of 4, which is going to be e to the natural log of 4 squared, which is 16. So as you can see, we have all of the dots. They're all positive. The y value is a little bit larger, so I'm going to scale my y's by 4. 4, 8, 12, 16. The x will stay as 1, okay? All right, at 1, I am 1. So I'm scaling it by 1, so my y's got to be careful. And I'm going to start right here. That's my starting point. At 2, I'm going to go up 4. At 3, I'm going to go up 9. At 4, I'm going to go up to 16. So it's right there. And then the orientation. So the most difficult is because of the property of log. All right. Thank you for staying, guys. That was so nice. I will stamp everything else on Friday.